Good morning, everybody, and welcome to today's session of Metrology Café. My name is Adrian Yates, and I'm here with our Senior Applications Engineer, Allan McNeil. Today, we'll be taking a closer look at the KSCAN-Magic handheld scanner from SCANTECH. Before we move over to Allan for the demonstration, just a few quick facts about the scanner itself. So the KSCAN-Magic, as I mentioned, is a handheld scanning solution. It features blue laser technology with 5 different working or scanning modes. It has large area scanning up to 1400 millimeters by 860 millimeters using the infrared laser. It also features 11 blue laser crosses for ultra-fast scanning mode, 7 parallel laser lines for fine scanning, or what we refer to as hyperfine scanning mode, features a single laser for deep hole scanning, and lastly, built-in photogrammetry for large-scale 3D measurements. KSCAN-Magic captures data at a rate of 1.3 million points per second with a 20 micron scanning accuracy and a 30 micron per meter volumetric accuracy. Let's now take a look. I'll pass the presentation over to Allan, but before I do, if there are any questions at all, please be sure to submit them in the chat box and we'll answer them at the end of the demonstration. Thank you so much. Enjoy. I'll now pass the presentation over to Allan. Thank you.
Thank you, Adrian, and thank you all for joining us today. Before we get into the live demonstration, I just wanted to run through a quick PowerPoint presentation highlighting some of the features and benefits and the various working modes with the KSCAN-Magic. First thing we need to discuss is the fact that this is a self-positioning handheld scanner. The scanner itself is not attached to a tracking device or an arm or a coordinate measuring machine. It does its own tracking based on affixing targets to the surface of the part that we're measuring. The targets can either be magnetic or sticker targets, and typically with this system we're looking at 3mm, 6mm, or 12mm reflective targets. One of the nice things about this system is you aren't tied to a specific brand of target. If you have targets from another system, they will work. We just change a couple settings inside the software. One of the most unique things about this scanner is that it has multiple different working modes. So it has the ability to change its field of view on the fly. It has a number of different light sources. So there are 3 different blue laser scanners, all of them having different working ranges. There's an extra large infrared scanner, which I haven't seen on the market before, but the infrared scanner is pretty novel idea and only exists with the KSCAN-Magic. We also have a photogrammetry system attached as built-in with this camera, with the scanner rather, which is also a novel idea, and I haven't seen that anywhere else in the market either. Most of the work that we do with the KSCAN-Magic is done in this ultra-fast scan mode, and it is ultra-fast. We're looking at 1.35 million points per second with up to 13 blue cross lasers. The field of view for this type of scanner is actually enormous. So it's almost a 0.5 millimeter wide by 300 millimeters across. And then there's another 250 to 300 millimeters in depth that you can use as well. So it's a really large field of view, which makes it a really efficient and fast scanner to use. The maximum resolution we can get out of this is 0.1 millimeter, and we're looking at an accuracy of 10 microns plus 30 microns per meter. The next system that we'll use with this is the single deep hole mode laser. It's a single horizontal laser stripe. And what's novel about this, or what's interesting about this, is for the cross scanners and for the parallel laser lines, we need to view both of those sets of lasers on the part with both cameras. Otherwise it can't capture the data, it can't calculate its location in 3-dimensional space. That's not so with the deep hole mode. So this projects just a single horizontal laser stripe and it uses only one of the cameras. The advantage of that is you're able to get deeper inside features, inside holes and pockets and that sort of thing. The hyperfine scan mode was a really interesting addition as well. So we've got a really large field of view with not an incredibly low resolution, but 0.1 is still pretty good for most things. But if we do need more detail and need more clarity in our scan, then we can go down to as low as a 10 millimeter resolution by reducing the field of view that the scanner is working on to 130 millimeters by 90 millimeters. And this works with 7 parallel blue lasers. Now I had mentioned the infrared laser, and infrared is off of the the visible scale of light. So you can't see it, so while we're working with this, the software actually projects a green rectangle so you can see the area that you're actually scanning, but obviously on the software you can see in the top right hand corner of that picture that I have, it's you actually see the scan coming into the software. This is basically a 1 meter resolution, 1 meter field of view that we're working with a minimum of a 1 millimeter resolution. So this is for scanning really, really large stuff. Regardless of what field of view that we tend to be using or happen to be using, we can start off our job by using the built-in photogrammetry. Because this is a self-positioning system and because the field of view is about 1/2 meter, once we go outside of that 1/2 meter volume as we're measuring and it's positioning itself based on the targets it sees on the part, you will start to see some stack up of errors based on the errors in one field of view as you're dragging along the part, or scanning along the part. The photogrammetry system can take out those errors, and it's almost a 4 meter by 3 meter field of view for that camera. Scale bars are included with the system as well as the coded targets, so the workflow would then be capturing all of the targets that you're using along with the coded targets within the field of view with this very large camera. And that ties everything together, and it also applies a scale to the measurements, and it allows us to achieve much better accuracy than we would if we hadn't used the photogrammetry system. Now, I've mentioned a few times the scanning field of view and why bigger would be better. So you can see on the side of this vehicle, on the left-hand side, we have one of the KSCAN scanners, and then on the right-hand side, it's kind of a typical size for the other handheld scanners on the market. Obviously, we're more efficient if we have a larger field of view, especially when that field of view has a pretty low resolution as well. So you can see that it would be more efficient. But the real thing that we're looking at in terms of improving efficiency and ease of use is if you have a larger field of view, you don't need to apply nearly as many targets onto the part. So that's really two benefits there. We can scan faster, but even in setting up the job, we're much faster, and we reduce the amount of time and cost of setting up the job on the front end. On the opposite side of that, what we have is a scanner with an incredibly high resolution. You can get down to 10 microns, and because it's using the blue laser, there really isn't a ton of noise that you might get with other systems, and I was absolutely blown away the first time I started scanning with this. Take a look at the gray image on the left-hand side here. This is actually the physical part, and you can see the targets that were applied around that part. That reflective center of that target is 6 millimeters in diameter. So the text that you're reading there up where it says on the top left-hand corner, this ABS plus PC, those characters are only 2 millimeters high, and then in the date and time codes you can see that those characters are probably about 1 to 1.5 millimeters high. And on the right hand side of the screen you can see this is actual scan data from this scanner having been meshed out. So we have kind of the best of both worlds with this scanner. We've got a very large working field of view as well as a very low, very tight working field of view where we can capture all these great details. All within one system and maintaining accuracy with that photogrammetry system as well. So that's enough talking. I'm sure you didn't join this just to watch me flip through some slides, so let's get started with the live presentation. I'm going to be using the KSCAN-Magic to take some data or capture some data on one of our demo training parts. I'm just going to zoom in here so you can see what the part looks like and how I've got the area set up. So on the part itself, it's a plastic part with a couple different pieces embedded in it, some very fine details. In this area here, you won't even be able to see them on camera, but when I scan them, you'll see them. There's a coin here, and then you'll notice I've affixed, as I mentioned during the PowerPoint, I've got a couple different size targets on here. So I've got 6 mil targets here, and then around the detail areas, I've also got some 3 mil targets, or roughly 3 mil targets. In the scene around the part, I've also got some magnetic targets. The table's not magnetic, but they work really well to just place on a table and then sweep them off after. What this is going to allow me to do is create a plane out of those targets and then use that as a clipping plane, so I'm not going to capture the scene all around my part, and it's only going to capture data on the part. So I'll zoom back out again. Moving into the SCANTECH software. Apologize. There you go. Into the SCANTECH software. The software is called Scan Viewer, Inside Scan Viewer, we really only collect data, although it does have some measurement functions, but for most applications we find you need to be going into a third-party software like Polyworks or something like that. Down the left-hand side, for collecting my data, there's only a few options that I need to change to be able to capture the information that, or capture the scan data. So I'm going to change the resolution to 0.4 millimeters. Now, if you've done some scanning, 0.4 millimeters might seem like it's not an incredibly fine or close resolution, but it's perfectly fine for capturing most of the details on most parts. It's just when you get into areas of high curvature or maybe a lot of tiny details and things like that where you might want to reduce it. And there's a function inside the software that's going to allow me to do that and overwrite data in certain areas on the fly. The exposure setting, there is a utility. If I wanted to run an automatic exposure, I can do that, but I just happen to know that we are somewhere around 2 or 3 milliseconds, so I'll use 2.5 milliseconds for my exposure setting. For those of you who haven't done much scanning, this is just how we capture different colors or different surface textures. So on a matte color or a light color, we don't need to have a very high exposure setting. We'll stay somewhere around 1 to 3. And then if we have a very dark surface or a very shiny surface, we need to increase it for the scanner to be able to pick up data on that surface. The next section here, as I said, we've got a multifaceted scanner, so there's a bunch of different working modes, and this is where I would manage those working modes while I'm scanning. But to get started scanning, the first thing we do is capture the mark points or the target points. So I'm going to leave this set to mark points, and I also need to tell the software that I'm using some special targets at a different radius than the standard 3 millimeters. Click apply, and I'm just going to start scanning now. So inside the software, what you'll see as I turn on the scanner is it automatically captures all of the targets that it can see within the scene that I am scanning in. Just going to turn that off, and just so you can see what I was doing live, I'm going to switch the feed, and we will do that again. So I turn the scanner on, projects light on the surface, and that's good enough. I've got all my targets. Having captured all of those targets, I'm just going to stop the scanner, and I'm going to instruct the software by selecting the targets that I placed around the outside of the part. On screen, you can see those highlighted. I'm going to click the background mark point setup, and I think I'll use just an offset distance of 0. So what this does, as you'll see, the targets are now grayed out, the ones that I had selected. The software will not collect any data below that surface. So that's pretty useful for me, because now when I switch over to the laser points and I start scanning, when I start to scan the part, it projects all of the cross lasers on the part, and I just start moving around. So you notice on the left-hand side of the 3D scene, or the graphics window there, I've got a traffic light style color bar, which is guiding me, and this is controlling how far away I am from the part. So as I move too close to the part, you'll notice I go down into that yellow zone, and if I move too far away from the part, I go into the yellow zone on the top. It's just guiding me around the part, making sure that I'm actually capturing data at the optimal distance. Probably be helpful now. I've pretty much scanned everything I needed to in this orientation. I'm going to switch the camera over to the live view, and I'm going to continue scanning just so you can see what that would look like. So turn the lasers on, projects a beam onto the part. You can see how large the field of view of that scanner is, all the way out to these points here and here. So an incredibly large scanner. This is actually a very small part for this laser. The more data I capture on any given surface, the better detail I will see on that surface when I'm done. So I'll stop that. I think I've scanned that part plenty, so I'm going to pause the scanner now. Switching your view back to the software. I normally do picture-in-picture, but I've found that you don't get the best resolution of what I'm doing inside the software, or you can't really see what I'm doing while I'm scanning live, so I figured I would just switch back and forth. Okay, so what you see here is the prepared point cloud, and what's really interesting out of this is if you've ever used a laser scanner, you'll notice I wasn't trying terribly hard to capture data on all the different surfaces. I was tilting the scanner around in different orientations, but look at the quality and the amount of data I'm getting inside all of these holes. On a single line laser, sometimes that's a very big challenge to be able to do. And you'll notice I didn't get a lot of data on the opposite side of the table. Normally I wouldn't be working in front of a camera, so I wouldn't worry about that. I'd actually just go to the other side of the table and scan that. This all looks really good to me, but what I do end up with, because I'm only using a 0.4 resolution, is not a ton of detail in this area where I've got some like date and time code stamped onto the part. So what I would do then is tell the software we're going to use the fine scan mode now. I'm going to select the high mode. I'm also going to select the selection button and just select the area that I want to replace the scan data in. So I've got that area selected, and then there's this coin over here. I may as well do this as well. So those are the two areas that I'm going to rescan. Going to hit the selection button again to get out of the selection mode. Start the scanner again, and this time on the back of the scanner there's a multifunction button which allows me to change the type of scan that I'm performing. So right now it's the multi-cross. If I double click it, switches over to the parallel lines. Parallel lines have a smaller field of view, and they also have a lower standoff, so I had to get a bit closer to the part. And if you wanted to see that, there's buttons on the back of the scanner as well to allow me to zoom in so I can see what I'm doing here. And just like any other scanner, you need to kind of move back and forth in a couple different orientations to make sure that you're capturing all the information off of that part. That looks pretty good for that one. I'll move over to this other piece here where the coin is. Okay, so I've got about as much data as I feel I needed there, but I'm going to switch the view of the camera over so you can see what this looks like live. There's my parallel blue lines. And at any point, if I want to, if I switch to the back of the camera here, this is the button I double tapped to switch the mode. Now I've moved into a single blue laser. Tap again, and we're back into the multiple cross lasers. There are other operating functions, as we had mentioned in the presentation, like given the current setup and the targets that are being used and the resolution that I've selected inside the software. It's pretty intuitive, and it won't allow me to use the large scale of view infrared scanner unless I make some changes here. So don't need to do that on this part anyway. So I'm going to hit the pause button. It has finished preparing my point cloud for me. And if I continue to zoom in here, there you go. You can see the incredible resolution we're able to get off of that laser. So there's no need for a part with this kind of geometry. It's fairly open. I've got some fairly large holes. If it weren't for this area here, where I might want to read this, and I should take a moment to point this out. This is the one I was talking about in the PowerPoint's presentation, but this just still blows me away. This is only about 1 millimeter and a bit high. That's 10, that's 20, that's whatever. And you can read the characters really well. So these are just under 2 millimeter tall characters, and just unbelievable resolution off of this scanner. And on shiny surfaces as well. That's the surface of the coin, and you can read pretty much everything off of that. When I hit the stop button, it will completely finalize the scan data, cleaning up some of the areas where there might have been a little bit of noise here and there. And there you go. That is the finalized point cloud. This is what we would take into the measurement software. And you can see after it's finalized it, you can even read the date here, 1980. And this gets even a little bit more sharp, because it's cleaned up a little bit of the noise that was on there. Okay. So now that we've got our scan data, we need to figure out what we're going to do with it. In this case, I'm just going to bring that data into Polyworks. We don't have time to go into a full Polyworks demonstration right now, so I've already prepared a very simple project, and I'm just going to load in the data and let the software complete all the measurements automatically. And that would kind of complete the workflow that we would see with this system. So you would do all your scanning in the Scan Viewer software with your scanner, and then export the point cloud, which I've already done, and we're going to open up Polyworks. So I'm going to switch over to Polyworks now. And here's my completed project. So I'm going to hit the new piece button. Software will create a new blank project for me, ask me to replace the demo that I just created, the data that I just created. Click the open button, accept the default values I have set up for my point cloud importation. So it's completing the best fit alignment over top of it's actually a polygonal model that I created off of the same part. Once it's done that, it's finishing its color map. And there you go. So we can open up our inspection report, and there is our completed inspection. So here's a new color map. Here's a close-up I took of that data. Won't show you that again. And there's the inspection of the 5 holes around the outside edges of that part. So at this point, that concludes the live demonstration. We're going to open up the floor for questions in a second, but I'll send you guys back to Adrian right now. Thank you again.
Great presentation, Al, of the KSCAN-Magic. I hope everybody found that very informative. It looks like we have a few questions, so we'll now open it up to Q&A. I'm going to send it back to Allan for his technical response. Back to you, Al.
Okay, great. Thanks, Aid. Yeah, so I'll just go through these. We've got some good questions in here. There was a series of 3 questions actually very specific towards a certain application in the fixturing industry. So can the scanner and its software be used to scan tools and generate shim logs? And once you scan a tool and shim it, would you need to scan it again to check the new location of a feature after shimming? And is this easily done with software? And of course, you wouldn't want to have to rescan the entire tool, only the area that you were shimming. So I can think of a couple ways, and thank you for the question. I can think of a couple ways you might want to accomplish this. I would encourage you actually to get in touch with us after this, because it's a really interesting application. I think it would do well. But to answer your question, what I would do in that case is, if this was the part of the tool that I was moving, I would avoid putting targets on the surface that I'm trying to check, but I would put the targets on things that are going to remain stationary. So as this moves and I rescan it, then I won't need to rescan the entire tool. The other option is I can have targets on this and I can have targets around the area. And before I rescan it, in the software, I can delete the targets that were on this face, and just by rescanning it, it will find out the new location again. So we really could handle this application pretty well. If you're interested and you want to follow up, please get in touch with us. This goes for everybody. If we don't get to your question, or if you had questions you hadn't asked, sales@cmmxyz.com. Just reach out to us at that email address and we'll get in touch and we'll figure out what the next steps might be for you guys. So I do have another question in here. How large of a file did this scan produce? So I didn't know, I just checked a second ago while Adrian was talking. This one, because of all the super fine detail down at 20 microns, I think it's 15 or 20 microns I was using in that area. Yeah, the file's quite big. So this is about 25 megabytes, but the scan at kind of the normal resolution is probably only around 4 or 5 megabytes. So it's really not a massive file until we get into these really hyper fine details. But typically you don't have too many areas where you would need that kind of resolution on a larger part. What is the minimum number of targets that you need? So bare minimum is 4 targets for the scanner to position itself over the part. And I've done very close to that. In this case, for the bulk of the part, I'm only using 6 targets, not even placed on the part, but around the part. And I've only used the smaller targets around those detail areas because I have a smaller field of view. So the scanner can't position itself on the larger area targets while it's scanning with the smaller field of view. That raises another question, actually, which is how do you determine where to place them? So depending on the field of view that you're working in, you need to use the smaller targets or larger targets, and they need to be closer or further apart. I guess the minimum spacing you're looking at is about an inch or maybe like 30 millimeters apart for the small targets on a small field of view. Through the ultra fast field of view, we're looking probably about 4 inches or 100 millimeters apart for your target placement. And then on the largest field of view for the infrared, we can get up to about 10-inch or 12-inch spacing. So that's about 250 millimeters apart for the targets. Then you need to consider how well you can see those targets and all the orientations that you're going to be measuring. So if it's a relatively flat part, you don't need a whole lot of targets, and the scanner is going to be able to see those targets from most orientations. But if you've got a lot of changes in curvature, you're going to have to increase the number of targets that you use. And I think I've got one more question here. So does the color or shiny parts affect the scan data? It's a blue light laser, and it's a pretty advanced camera technology. So you might find some cases where at the extreme ends, a really shiny black part, you might have some difficulties in certain orientations, but for the most part, the scanner is very insensitive because of blue lasers to different surface textures and things. Even within a single scan, scanning a black surface versus, say, a white surface in the same scan does a really good job of capturing like different textures within the same scan. And one final question here. Given the scanner is line of sight, can a part be physically reoriented mid-scan to capture surfaces not seen? There's a couple things that we can do in this case. If you're, say, looking at a part where you want it to be able to scan both sides, so the top and the bottom in one scan, what I would do is target up the top of the part, target up the bottom of the part, and then place targets all around the outside of the part as I'm getting started. So when I'm scanning at that first stage of the process where I'm just scanning the targets, but not actually collecting the laser data. After I flip the part over, the software won't immediately recognize how all these things fit together. But once I've scanned these targets and the targets on the side all the way around, and these targets and the targets on the side all the way around, it'll do a best fit and figure out where all of those targets should be placed or how all these targets fit together on a single piece. So then I'm able to just flip the part over and scan on any side I want, and it'll track and just give me one cohesive set of scan data. If for some reason the part is too large and I'm not able to scan it or it's obstructed view or whatever, the one thing that I would need to do then is make sure that I'm scanning in the first setup and the second setup, there's some overlapping targets, say on a very large part where I'm doing the top and bottom, but I don't have the ability to reach all the targets in the second from the first position. As long as I've got overlapping targets around that part, I'm going to be able to get the software to do something called splicing, where it will fit the second set of scan data to the first set of scan data based on whichever targets it sees overlap between those two sets. So that's a great question as well. Like I mentioned, the email address is sales@cmmxyz.com. If you want to get in touch with us, I'd encourage you to do that. We've only just touched the surface of what this particular scanner, the KSCAN-Magic, is capable of. And then through the entire product range from SCANTECH, there's a lot of really interesting technologies. So once again, thank you very much for joining us. We hope to see you again.